Hi, everybody. Thanks for coming. I think Tala introduced me. I'm software engineer at Databricks. Currently, I work on Apache Spark. And prior to this, I was software engineer at Apple. I worked on Apache Iceberg. And so I'm an Iceberg PMC member. I'm actually really excited. This is my first time talking about some of the work I do in Databricks. We started even before I joined Databricks and Apple, but it's called DSV2. It's the integration of Spark and Iceberg. Just for reference, my tech lead, Anton in Databricks, he made a talk earlier this year at Data AI Summit called The Future of DSV2. So if you're interested in like the future of it, I recommend to see his talk as well. Yeah, let's just get started. So first, a brief overview of Spark and the data source ecosystem. Apache Spark, I think most people know about it. It's an open source project developed way back in 2009 by UC Berkeley AmpLab, who went on to found like Databricks, became Apache Project 2013. And essentially, it's like one of the best open source distributed processing engine for analytic data sets. I think it's really hard to match the scale of Spark in this category. And then it's very user-friendly. There's so many different workloads it supports, right? Like the streaming, ML, Spark SQL, PySpark. But all under the hood, Spark has kind of a database-like architecture. You go from parser to analyzer, optimizer, going from logical plan to physical plan to optimized plan, then to the distributed execution. And for the purpose of this talk, I'll explain like Spark. Another strength of it is that it supports a lot of data sources. So you can apply all its like distributed processing and all its database optimization on any data source. And so that's what I'll talk about today. So Spark has a data source API, and data source API is the boundary between the compute and storage for Apache Spark. And by implementing this API, you can allow Apache Spark to read and write to any data source. And you would think, like maybe it's a small API, right? Like how hard can it be? Maybe just the reader-writer API. But actually, it's much more than that, just because one, Spark is like a database, has many optimizations, and two, it's distributed, right? So this API first needs to be distributed to support like a parallel reads, parallel writes. And then it has to have a lot of hooks. A lot of database optimization need the storage format to support, for example, pushing down things like the push filters, pushing down predicate pruning or column pruning, joins, even reporting getting statistics from the data source to make a better cost-based plan. And then entire new features of Spark in the SQL language need data source support. For example, DML, it doesn't make sense for any data source. Data source needs to support the updates for DML to make sense. Transactions, right? The data source needs to support coordinating commits. CDC, it needs to support the concept of a snapshot and then reading difference between two snapshots. So there's entire features of Spark that are reliant on a data source, and therefore DSV2 will need to cover this as well. So that's why it's a huge project. And Apache Spark for a long time has this thing called DSV2, DataSourceV2, which was to revamp DataSourceV1 API. And for some kind of fun fact, a lot of the early Apache Iceberg founders, like Ryan Blue, Anton, they collaborated early on with the Spark community to make DSV2 and to make Iceberg the first implementation. So that's why, like I think Kevin was mentioning, Spark is, for historical reason, the reference engine for Iceberg. Like any feature that Iceberg does, the question is, how does it work end-to-end in Spark, usually in the dev list? And so these benefit both communities. Iceberg from early on got access, like almost native support from the world's, almost premier, most popular and most powerful open source engine. And then Spark got database functionality, right? Like it was not really ACID compliant, now it is. And then Spark can also, by abstracting this out, if the data gravity changes, later on, obviously we hope Iceberg will be forever, but if it changes to something else, Spark is in a better position to natively support this new thing. So hopefully I explained the benefit of having a good data source API. And I'll talk about like a little bit like what the data source V1 API look like and go into DSV2. So this talk is more just like dive into various aspects of the API. So data source V1 API is a set of Scala traits. In Scala, a trait is something like an interface. It's just like an empty class with a method, but no body. And so the data source actually needs to select a few of these traits to implement. And that's how the API works. in Scala it's called mixin. And so there's some base traits that needs to implement, for example, relation provider, relation. In Spark DSV1 language, relation is like table. But you can implement other traits to signal to Spark you support other things. For example, if you support read, you implement the table scan traits and you return RDD to Spark. If you support an optimized read, you implement the prune filter scan, and you can take a set of column and filters and return a prune RDD to Spark. If you support creating an instance of yourself, like creating a table on your data source, like Parquet, then you implement creatable relation provider. I'm not going to dive too much in detail, but overall, DSV1 has some really good points. It was very elegant and concise because like the declaration was the implementation. By just implementing the trait, you already signal to Spark, I support this. So the Spark optimizer can already do something for in preparation. And also that's the implementation itself. Spark would just call you. So all in all, I think this is really cool. The only con was this API started to become kind of old, like RDD, as you know, become kind of internal to Spark. Now Spark has a better API like data frame datasets. So it started leaking some internal API. But overall, I think I show you because this is actually a really good design and we keep this for the DSV2 API. It's actually what the DataSourceV1 didn't have that make us go to DSV2. So what it didn't have is a catalog plugin. And so what it means is, I think everyone knows catalog, but in Spark world, a catalog is, the thing that you use to, or Spark uses to update or create a table, alter table, delete table, obviously. But catalog is also what you use to resolve the table during queries, right? You just put some select from table and then it has to look in the catalog to resolve what that table is and the columns, obviously, of the table. Spark has, obviously, a catalog called session catalog, but unfortunately, this was in the early days, and so it was actually a wraparound Hive Metastore, and there's a lot of problem with that. Hive Metastore, as you know, a lot of the Iceberg design choices was to because Hive Metastore was designed for Hadoop file system, have Hive style partitioning based on the directory structure. Like Dan said, it's a little outdated. And Spark not having a playable catalog kind of bound it to this old style behavior. And then Spark cannot also adopt to new table format functionality. A lot of new table format is introducing new metadata to a table, right? Like different column metadata, partition transforms. By having a stuck catalog, Spark cannot adopt any of that. And then it has to be in Hive Metastore. Like Iceberg now has many catalogs, right? REST catalog is the new one. And so Spark not being able to plug that in, we just make it not work. It can't resolve anything not in Hive. So that's why one big problem that DSV2 tried to solve. Second big problem is a lot of the new table format need commands, SQL commands. As you know, Iceberg has this kind of infamous table maintenance that you need to run, right? Like by calling rewrite manifest or expire snapshots. And the way, even today, like the way Iceberg does it is suboptimal. It has this thing called, if you only look at the Spark-Iceberg setup, you have to put this extension. And this is a very hacky one because this one is actually injecting like parser in front of the Spark parser to get the SQL statement and then parse it in Iceberg, return to Spark, and then inject rules like to further resolve it. So it's actually really bad design. And then the worst thing is like not just Iceberg, but other table formats like Hoodie, Delta Lake, they all have this pattern. And so it's very fragile and something that DSV2 tries to address. So hopefully that explains some of the problem of the DSV2 try to solve. And then I'll go into the DSV2 API. So DSV2 is like DSV1 on steroids. There's like a whole set of traits. So like traits work really well, so we continue that, but like even more. So we'll have traits even now to plug in the catalog. I'll talk about later. But for example, over table, you can now have traits to say, I support read, support write, support new things like metadata columns that Iceberg supports. And then once you're ready to read, there's a scan builder with traits that you can implement. For example, I support an optimized read where I can push down filters or push down column pruning or aggregates, push down join and limits. So there's even JDBC data sources that can benefit from this API. In fact, they do today. You can push down entire joins to the data source. And then once you have the scan, once you're ready to read, you make scan, and there you can say I report statistics to Spark. And Spark, if you do, then Spark can read statistics for cost-based optimizer. So that's, Iceberg has the Puffin files that you can read from. You can say I report my ordering or partitioning, and Spark can actually skip like entire shuffle or sorts based on that. And then once you read the distributed read API is called batch. It's a bit confusing if you see that because it's different from micro batches for Spark streaming. But the batch has support to create a list of input partitions and then a partition reader for each partition. And there you can decide, do I want a columnar reader? Do I want a row by row reader? So all in all, it's like 8 levels of like various optimization that the data source can opt into. And we think this is like really future-proofing Spark by exposing all its like optimization to the data source. And so to give some light on some of this, because it's kind of boring just to see a list of API, I'll talk about some example that kind of like illustrate how Iceberg uses this. So support a pushdown filter. This is where Iceberg kind of shines, right? Or a lot of the table formats. If you have a query, say select from my table where ID equals 1, Spark can push down the ID equal 1 down to Iceberg, and Iceberg via the partition stats and the min-max stats from the metadata files can print out data files that don't match the filter. Similarly for push down required columns, if Spark has the query is select like one column from the table, the Iceberg can, by implementing this, can take that column and then when it makes the reader for the data file, it just reads that column from Parquet or ORC, which is much more efficient because the column is the data is a columnar format. And then support push down aggregate, Iceberg implements this too. If you have some basic aggregate like count, min, max, Iceberg can get that and then use the metadata from like the min, max, and counts from the metadata to answer that question. So these are some of the basic database optimizations. I want to talk a little bit about this one. Is a more exciting optimization. I worked on this a lot in Apple called the storage partition join. And there's a talk I gave last year in the community over code if you're more interested in details. But Spark can skip entire shuffles. So shuffle in Spark is very expensive. All the data needs to be sent across the network. And the way this works is that, Spark is a database, right? So it has this plan. So if you see this example, select from join T1, join T2, it makes kind of a logical plan where it has a join node and 2 children, each being the table. And the way the Spark planner works is the join node will request its children to be distributed a certain way. And for joins, it has to request the children to be hash distributed because by the join key, that's the only way to guarantee correctness of the join, right? If the same row of the same join key flow to the same partition. So what happens is actually for a data source, what we can do is report to Spark, we are already partitioned and we're partitioned by this key. And if Spark sees that's the same as the join key, it can actually not insert the shuffle on top of the children. So this is like huge optimization called the storage partition join. And it's a good example of how Spark can open up its internals to a lot of data source optimization. Other optimization that the table format can also participate is small files. And small file is a kind of infamous problem in the data engineering world. You may have some table that has so many files that you can't even like read it or even delete anything anymore because it takes so long to list the files. So we want to avoid that. And there's obviously very many causes for small files. Maybe you commit too frequently. Maybe you have too many Iceberg partitions, like you partition by a high cardinality column like ID. Then you have a million partitions. You can't do much there. Maybe you have too many Spark partitions. You say like the last phase, you set the parallelism to 1 million. That's then each writes one file. But these are all user errors. And what Iceberg can solve is actually the non-user error and actually help you in the problem. Because a lot of the cases, just by default, the file tends to amplify number of files. Because if you think about it, you have n Spark tasks. N doesn't even have to be very big, but you have m Iceberg partitions you're trying to write to. By the chance, each task will have to write to every partition because the data is random. So then you have n times m files, which could be like very big, like millions, right? And so what Iceberg does is it can actually do implement another trait called requires distribution ordering. And you may have seen this in Iceberg. You can set in Spark like a table property saying I want to write ordered by or write distributed by. And then using the same mechanism for an insert query, you have the v2 write whose child is the query. The v2 write can request the children to be sorted or shuffled, distributed. And then Iceberg or Spark will just insert the sort or the shuffle before you. obviously this is not for free, like it takes now longer to write, but we find that a lot of cases it's much more preferable to having an explosion of small files. But I think that's, so the optimizations on the catalog side, very happy to say for DSV2, the catalog API has finally got a revamp, and now we have a pluggable table catalog API that has a lot of these kind of like modern concepts, multi-part namespace, right? Like maybe the Iceberg REST spec supports this, and now Spark can optionally, you can tell Spark you support that. And then partition transforms, which is an Iceberg concept, hidden partitioning. Now the API supports that. And then Iceberg can have different implementations, right? Iceberg, maybe the story of Iceberg catalog is started from an Iceberg Hive catalog and it's moving to REST catalog, and now you can have actually each of them implement this Spark catalog interface. And then the cool thing is that you can actually now, and this is from the Spark Iceberg quick start, you can, it already shows you how to specify multiple catalogs. Maybe you have a Hive catalog that's old and then you're trying to move to REST catalog. You can actually specify multiple catalogs and then reference entities across catalogs by just doing catalog.namespace.table. So I think it's really cool. It's called catalog federation. And for DSV2 data source, it benefits from it. And you can query across catalogs. And then, catalogs are so cool that we kind of continue the concept. And this is all kind of new work. I think seeing this land in Spark 4.0 is that table format, despite its name, is much more than tables and columns. Iceberg has a view spec you may know about. Iceberg has functions, which are the partition transforms. And Iceberg has these maintenance procedures that needs to run, right? Like rewrite data files, rewrite manifests, expire snapshots, remove orphans. So we make even more catalogs like view catalog, function catalog, procedure catalog that Iceberg can plug each of these in. And the benefit of this is now it's native support in Spark. So Spark, when you query and then you say partition transform, Spark can just look at the function catalog to resolve that. You benefit from show and describe in Spark. You now show your procedures, like describe each procedure. And then you can call the invoke procedure in the Spark query. So it's all pretty cool stuff and kind of kind of hot off the press for Spark DSV2. And then DML, I think, it's a whole different beast. I don't probably have time to go too much into it, but DML really is, I think, the game changer why Iceberg became popular. People wanted to have the ability to update, do row-level updates on data at huge scale, while being protected from concurrent updates or concurrent inserts and things like that. So this is not possible in the, pre-Iceberg days. And so you have merge, update, delete, which are now very popular statements for data lakehouse. And these also are the ones that use the most advanced Iceberg features that everyone talks about, right? Like people talk about deletion vectors all the time, but normally you don't get deletion vectors unless you use some of this delete statement or update statement. And row lineage is a new cool feature that, if a row is updated, the row ID is kept the same. And that obviously only makes sense if you have an update statement. So this is a whole new set of thing that we developed for DSV2 to the language. And the API for this is it's more than just read and write. Actually, it's a read and a write, because DML is data manipulation language. Like you're reading some Iceberg table, you're doing some distributed processing to for example, delete from. You want to calculate what to delete from, and then you write that back. And so this is a read and a write. And then there's a Uber API called supports row level operation that binds together the scan builder and the write builder from the previous slide. The reason, and for Iceberg, it's important to have one object because for ACID to work, it's using the snapshot concept, right? Like when you read, you're reading table from one snapshot, and when you commit, you want to make sure in the middle there's no conflicts, intermediate commits that conflict with you. And so that's why it needs one object in the API in order for the data source to do proper ACID transaction. And this is also where the deletion vector comes in. And so if you're curious how this works in Spark, there's another trait that you can implement called the supports delta. They call it, this is not delta leg, it's supports the difference like a delta. And basically this means that, you're telling Spark, so this is really cool because you're telling Spark that I can work with just partial updates. I don't need the whole data to replace. And so Spark, when it does the join for a merge, you can do optimal join where it just outputs the difference, like what rows are deleted, what rows are new, instead of like, the original data that, traditionally you had to do. And then you could call it delta writer and actually pass you deletes, like this row is deleted position XYZ. And then Iceberg can write the deletion vector that everyone hopefully maybe knows about, right, in V3. And then for row lineage, this API also returns like a row ID so that Spark will know, oh, this is the row I need to keep. The row ID, this is the field I need to keep for updates, right? This is the row lineage feature for Iceberg V3. So, so what are some possible directions for what's next? I mean, this DSV2 project has been going many years. I mean, if we started in Apple, continue in Databricks, it can keep going. And then maybe multi-table transactions can be new. And by the way, this is already supported in, I think, or at least there's proposals for it in Iceberg. And I know the Iceberg West Catalog already supports like having multiple tables in a transaction. So maybe Spark can expose this and finally support begin transaction, do something, end transaction. There's many table format features that are still being implemented, right? Identifier, or some already there. Identifier column, generate column, default value expressions, table constraints, your primary key, foreign key, check constraints, unique constraints. And so these things, I think like Spark DSV2 API is expanding. We're doing a lot of work there to expand that, the language support and the API. And then with this deletion vector, I think it's also really cool. It opens up a whole set of use cases to finally do like better incremental processing, which is, traditionally Open Lakehouse is not that good at. So CDC, I think, requires a lot of work, but, hopefully with deletion vectors, now you can have quicker ways to find difference between two snapshots. And then materialized views is kind of like, the holy grail. Like the ability to have a materialized view and then incrementally refresh it, I think depends a lot on the CDC, which depends on deletion vectors. So I think there's a whole roadmap of things we can do in DSV2. So I ended up a bit early. But yeah, thanks everyone for coming into the talk. And thank you.